Okay, absolute value function. You guys remember the standard form of a quadratic equation, right? Sure you do. And we talked about it already, didn't we? Where's my pen? Where's still my pen? Okay, standard form for quadratic equation is what? Y equals ax squared plus bx plus c. That's called standard form of quadratic equation, right? Well, absolute values have their own standard form, okay? And we're going to call this form vertex form. And I talked about this a little bit in the past couple days, right? Vertex form says, well, I have this y equals a times the absolute value of x minus 8 plus k. Now, let's define some of this stuff. A is going to be our slope. And hk is going to be our vertex. Now, be careful when you're trying to pull the vertex out of this formula. Notice the signs. This sign has to be minus. This sign has to be positive or plus. All right, you already know. Oh, by the way, we're going to be studying a bunch of functions. The next one is piecewise functions, and then so you're going to really have, and then we're going to understand the transformations, and you're going to apply this to the different functions we study. So if you don't know the transformations of absolute value functions, or you don't get it, guess what you're not going to get in the next section, and the next section, and the next section? The transformations of different functions. Okay? So please focus, take good notes. All right, you ready? Y equals the absolute value of x. This is called our parent function. I don't know, put mother graph. I think somebody was very angry. All right, so if I were to call it the parent graph, that's what it really is. If I were to graph this, how would you graph this function not knowing anything else? By the way, to graph anything, and you're stuck on the SAT or ACT test, you can always go back to t-charts, right? Let's make a t-chart. And here's my x, here's my y. Which one do I choose? That's right, the independent, the x. What's going to be the easiest x to choose? That's right, 0. Okay, if I plug in 0 for x, I get y equals the absolute value is 0, which equals, thank you. So there's 1 point for my relation or equation, right? I'm going to choose what's going to be the next easiest. 1. So y equals the absolute value of 1 is what? Thank you. So I chose 1, I get 1. You know, just for the heck of it, let's choose -1. Exactly, because anything that comes out of the absolute value signs has to be positive. So that's going to be 1. What if I chose -2? 2. What if I chose 2? Now you got it. So let's plot these and graph. So I have 0, 0. I have 1, 1. I have 2, 2. And negative 1, 1. And negative 2, 2. So here's my graph. There's the parent graph, x or y equals the absolute value of x. I'm sorry, what was your question? What do you mean? Well, I'm glad you asked. In the equation, y equals the absolute value of x, you're saying, well, how can I use my formula? Well, we can. What's my a in this equation here? What can I multiply to not make a change? 1. So my a is 1. My a is 1. I have the absolute value of x. Now, what can I add inside? Because inside the absolute value, I'm going to subtract something without changing the value of x, which is 0. So I have x minus 0. So I have my a is 1. My h is 0. What's my k? 0. So I'm adding 0. So this is in vertex form. It's just that my a is 1, my h is 0, and my k is 0. Okay. And I could have just looked at this equation instead of making a t-chart and know that my vertex was 0, comma 0, my hk, right? Was 0, comma 0, and I heard you say that the slope was 1. So if I started at 0, comma 0, I could have just gone up 1 over 1, up 1 over 1, up 1 over 1. So I could have done this without the t-chart. And because my negatives come out positive, I can't go 1, negative 1. It has to be positive. So if I go up 1 to the left 1, up 1 to the left 1, up 1 to the left 1, yes, I could have done it several different ways. Any questions? All right, you ready for the transformation? I don't. All right, number 1, here's our transformations. Remember, our transformation is nothing more than making shifts to our parent functions. So I'm always going to be comparing things to the parent function. In this case, our function is the absolute value function. Okay, so there's my parent function. Why? This is my parent function. That's y equals the absolute value of x. It's always going to be a v. Absolute value function is always going to be a v. Because we just did it up here. I just spent the last 10 minutes doing that. Yeah. I just put it on there so that we can compare it. Instead of just pointing up here, now I can point right on the graph. No, we're just going to do it to the first one because I think you'll get the idea of the shifts. Wow, you guys are impressionable. And I'm not even very good at English vocabulary. All right. I have a minus 2 inside the absolute value symbol. So I have something inside the absolute value symbol. Hang on, let me catch up. Inside the absolute value symbol, so what is that going to represent, my H or K? H. So this is the H inside the absolute value symbol. And Martin's right. If you remember back to Algebra 1, when you were doing quadratics, inside the parentheses, you shifted it left or right depending on the sign. It's the opposite of the sign. Okay. Inside the absolute value symbol, you're going to shift opposite the sign. So if I have a negative sign, or if I have a positive sign, I'm going to shift it, you would think, to the right, but it's going to be to the left. If I have a negative sign inside the absolute value symbol, I'm going to shift it to the right. Now I'm talking about the vertex when I say shift. Ready to shift? What am I going to shift here? So I'm going to shift the vertex where? To the positive 2. Everything else stays the same. We're not doing anything else to this. Okay, so I'm just going to shift it, the vertex, to the right 2. Everything else stays the same. There's my transformation. Because I just happened to put more dots in it. Are you taking notes? I didn't think you were serious. All right, you get it? You get inside the absolute value symbols? Look at the next example. Number 2. Which way is this thing going to shift? Left 3. I thought you said you guys didn't get it. Okay, wonderful. All right, so my vertex is normally at 0, 0. You told me to move to the left 3, which is correct, by the way. So 1, 2, 3. Nothing else is changing to my parent function. We're just shifting to the left 3. Everything else stays the same. Up 1 over 1, up 1 over 1, up 1 over 1. Because my A is still 1. That's my slope, remember? 1 over 1. Wait, I got like 3 different people asking me questions. Cat. Oh, you mean like number 5? We'll get to that. Question. No. My slope is 1. I didn't know why. I am trying, I just haven't finished. Do you want more dots or less dots? More dots? Because I moved it to the left 3. I moved the vertex to the left 3. So you want me to draw the parent function and the shift? You don't need to put the parent. I just did it for teaching purposes. You don't have to put the parent function on there every time. Are we good? Any more questions? No. No. It will. You think this is bad? No way. Why is what? I don't know what you're saying. Then you would have to show, you have to explain why, and you would have to use a T-chart. That's a nightmare. No, leave it alone, my son. I see where you're going, and I think it's a great idea, just maybe not with this group. All right. Number 3. What are we using in my formula? Y equals A times absolute value x minus h plus k. Now what are we adding to this? 2, which is my k, right? It's outside the absolute value. So now let's talk a little bit about k. We're adding outside the absolute value symbols. We are no longer inside the absolute value symbols. So we're going to move up and down. Yes, outside the absolute value symbols. You're going to move up and down. Yep, this one's left and right. I know, but I'm saying. We're going to shift up and down, and we're going to follow the sign. So if I have a plus sign, I'm going to go up. If I have a minus sign, I'm going to go down. Are you ready? Okay, what's my shift here? 2 up. Okay, so I normally start at 0, 0. I'm going to shift it up 2. 1, 2. Any other changes to my parent function? No. So I'm going to go up 1 over 1, up 1 over, using the A as 1, that's my slope. Up 1 over 1. You want more dots, Jenna? Fill up the whole dot. And then this way, I'm going to go up 1 over 1. Yeah, that's good enough. You are correct, my son. That's it. I'm done. Unless, of course, you want to put the parent function in, and then you get another gravity. Such harsh language after I take all this time to teach you guys. Wow. I see the respect I get now. Questions? Anybody? Raise your hand so I can call on you one at a time. Shoot. Yes. Martin. Brandon. I'm not done yet. It's going to be, yeah. All right, number 4. What is my shift? Down 4. So that's my shift. So I originally start at 0, 0. I'm going to go down 4. Any other changes to my graph? No. Up 1 over 1, up 1 over 1, up 1, up 1 over 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 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I'm done. Okay, won't the rest of the course be so simple now that you know transformations? Well, let's talk about that for a sec. Okay? Now you're getting with the changes to the slope. Which are our next two problems? Thank you. If my A is negative, right? Now my A isn't just 1 anymore. My A equals -1, correct? Anybody not see that? Anybody not see that my slope is now -1? Because there's a negative sign in front. That's my A, -1. Okay? So what's it going to do? It's going to, if my A is negative, it's going to flip my graph. Wait, this is the first flip. Okay? So, instead of going up 1, I'm going to down 1 over 1, 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 down 1 over 1. Okay, and the other side? Down 1 over 1, 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 down 1 over 1. Now, just think if you were absent today and you had to watch, I made you watch a video online. Down 1 over 1. Okay, any questions about when my A is negative? No questions? Okay. All right, number 6. What happens when my A is 3? Very good. You change the slope. What is my slope? Up 3 over 1. Okay, so any other changes to this? Okay, so I start at 0, 0, up 3 over 1, up 3 over 1, up 3 over 1. Oh, that's all I get. Up 3 over, by the way, the vertical line that goes through the vertex, this one happens to be x equals 0, right? Right? Shut the door. Shut the door. Richard, shut the door. Hurry up. He's going to come and yell at us. Thank you, sir. Okay. Oh, thank God I was recording now. All right. All right, quiet, quiet. This is important. This is called the axis of symmetry. It is. Richard got up and locked it. Code red, code red. Lock the doors, lock the doors. What movie was that? Code Red, Code Red. The guy with the baseball bat, the principal with the baseball bat. Stand by Me? Is that it? No? Is it? I don't know. What's it called now? Now I'm confused. Three is the vertical line that goes through our vertex, and every point is equidistant from one side to the other side. In other words, one side is exactly like the other side. So it's symmetrical. Very good. This one's 2 points away, so this is 2 points away. That's funny. Okay. So, how can we sum this up? What happened to my graph? All right. What happened to my graph here? It's higher? More narrow. It's narrower. It's been smoking dope. So here we go, dope talk again. All right. So if my slope is greater than 1, my graph is narrower. Okay. Now, what do you think would happen if my slope was a fraction between 0 and 1? Be very wide. Now, we have some mathematical terminology for narrower and wider. For wider, it's called compressed. And for narrower, it's called stretch. Now, most of you probably are not going to go on further in math. So if you put narrower and wider, I'm okay with that. If you're going on in mathematics, get used to compress and stretch. Any questions? I think that's enough for today. Now, on the back. On the back. See how many of these you can do. Let me help you out. In this course, look at our V. In this course, what's going to always be my domain for the absolute value function? What is it? Negative infinity, positive infinity. Okay, it's always going to be negative infinity, positive infinity. For this course, the domain of our absolute value is always going to be negative infinity, positive infinity. The range is going to depend on what? What do you think? What do you think? What do you think our range is going to depend on? Nope. Yeah, what part of the vertex? What's my vertex here? It's HK. Okay, my K is -4. My H is 0. No, I'm getting it from my formula. Okay. When listen to me. I'm getting this from my formula. Okay. My vertex is HK. My H here is 0. That's what's being added inside my absolute value symbol, right? My K, this has to be a minus sign. I'm sorry, a plus sign. So it's the opposite of the sign, -4. So my range is going to start at my K. Okay? So my range is always going to start at my K. It's always going to include it. And depending if there's a negative sign there or a positive sign for my slope, it's either going to be positive or negative infinity. Okay? So there's not a whole lot to figure out for domain and range. Well, what am I subtracting from x? What am I adding outside the absolute values? What's my slope? What's my a? Okay, vertex 0, up 2 over 1, up 2 over 1, up 2 over 1. Axis of symmetry, so it's going to be the same distance. My domain's always negative infinity, positive infinity. My k here is what? Good. So 0. And is it going up or down? So it's positive infinity. That it could take you could probably finish this page before you leave.